All right, welcome to Earth Science, part 2 of Igneous. You should have this filled out now. If you don't, stop, get to the end of the last video, see how you do it, make sure you get that done. I promise it'll be less work later. You're actually, if you don't realize it, kind of doing your lab so that when you open up the lab, you can just blast right through it if you've done all this. Okay. A couple quick notes just to like reinforce what we said above. Texture refers to the grain size of the minerals of the rock. So again, it's not how it feels. I could hand you a coarse igneous rock. In fact, if anybody has granite countertops where you can see the bits, those have been polished very smooth, but I'm telling you it's a coarse rock. All right. So keep that in mind. You got to get it out of your head that texture is how something feels. Vesicular, an igneous rock that contains gas pockets. Why? Because of the release of CO2. I don't know if you want to be a particular here and make sure that you do it below. In fact, that should be uppercase too, but whatever. CO2. Nope. Not the way that I have it stated here. Because of the release of pressure, it allows CO2 to convert to a gas. So again, just like the 2-liter soda bottle, you shake it up, there's CO2 in the liquid. You take the pressure off of it, that can convert to a gas. It's not being compressed by the pressure inside the bottle anymore. That pressure is released. Foam comes out. If you could like instantly freeze that foam, that's essentially how a vesicular igneous rock forms. Glassy. Sometimes an igneous rock cools so quickly that crystals do not form. This is kind of complicated, but once we get to minerals, we might, if you can keep this straight that long, this technically doesn't even obey the rules of being a mineral because it doesn't form a repeating matrix of like the atoms that are in there. You get this kind of amorphous blob stuff that forms a glass. And it's actually one place where the rules get broken too. Pay attention to that because that's going to pop up in your lab. All right. So time for the reference table. Let's do it. Let's go a little smaller. Let's get my stupid head out of the way. Yeah, 125. Okay. So again, this is the biggest and most intimidating of all the reference tables, but again, the rocks are actually the easiest. All you're going to do when it's time is go with, is it a lighter color or is it a darker color? Or I'm going to throw an I right here. If you'd like to join me, you can. For intermediates. So the lighter colors Felsics, darker colors Mafics, job done. I'll tell you, these are the ultra Mafics. And I'll promise I won't give you any. I wouldn't like scratch them out in case they somehow appear on a regions question. I've seen that once. But on my lab, you can do a minor X out if you want. On my lab, they won't be there. So your Mafics are here, your Felsics are here, your intermediates are here. Next, and this again is the place where people that are clever that figure out how this reference table works can walk into that test with almost empty-headed. You don't have to memorize any of that intrusive, extrusive stuff I was babbling about. If you're clever enough to use this table and say that intrusive rocks, over to here, whoops, without that line, intrusive rocks, what are they like in terms of their texture? Well, they're either coarse or very coarse. Very coarse ones are going to be ones that cooled for a really long time. I've got some here in the room. I did not put one in the lab because it's just not, I don't think it's really fair. It's difficult to make that comparison between those two. So there won't be a pegmatite, though I've got some here. So intrusive, cooled inside, cools slowly, forms non-vesicular coarse textures. All that information's there for you. What about extrusive, rocks that have exploded onto the surface of the earth and cool quickly? I guess maybe that's the one thing we got to have in our noggin. So maybe not a terrible idea just to say it again because it's the one thing. If it's intrusive, it cools slowly. Extrusive, it cools. Yes. Okay, so what if that's the case? Well, then the texture is going to be either fine or vesicular or glassy. And then sometimes there's some funky spots where it kind of mashes up and you get a bit of both. But I'm unlikely to be that mean on the lab. So what do? We see if it's light, we see if it's coarse or fine or glassy. We see if it's in the middle, and we see if it's coarse, fine, or glassy, or vesicular. And if it's dark, do the same thing. So how about we were to take this? If it's extrusive and felsic, it has a fine texture and a light color, where am I at? Felsic, right there. Yeah. I already forgot that. Fine texture, right there. So I'd be basically on the felsic end of the spectrum and in the fine end of the spectrum. So I would say that rock right there, which you will see in the lab, is rhyolites. I won't say go back and do all 6 of those, though you're welcome to. Because again, I'm promising all 6 are on the lab. Then when you pick up the lab, you're just going to, again, blast right through it. What minerals are in rhyolites? Let's see. Let's just do a Google image search. Kind of looks like that. Oh, does that look familiar? I didn't take any pictures off the internet. So if I wanted to know what minerals are actually in there, the reference table hooks me up with that too, because it's over here on the felsic end. So I would expect if I were to extract it, figure out, or use it, cut a thin section, do a slide, whatever, I'd expect to find potassium feldspar, quartz, plagioclase feldspar, biotite, and amphibole. Those 5 things are likely to be there. These proportions, they haven't really asked about those in years. Like, does it have a lot of potassium feldspar versus a little quartz? You know, and things can be like felsic, but a little closer to intermediate. This is all a sliding kind of scale that we have defined, but it maybe gets a little bit. What if it's a very intermediate, but still felsic? Now, I won't make you delineate between those, but they exist. This is a continuum between those. Okay. So that's it. Light colored ones. I'll give you a light coarse, a light fine, a light. Did I do the glassy? Well, yeah, because pay attention to this. Obsidian's a rule breaker because of that glassy thing. It appears black, even though it's made of minerals that were they to properly form, they'd be light in color. Then I'll give you some intermediate ones and some mafic ones, and you just line them up like that. The lights, the darks, the coarse, the fine. Boom, boom, boom. Job's going to be done. You'll blast right through it. Okay. Here's a couple of questions that I'll include, I'm guessing, at some point. So I'll leave this to you, whether you want to be the type of student that's going to like, why don't I try these quick since we're popping these ideas around in my head. They'll probably show up on one of the classworks, but I'll recopy them so that you don't have to go and try to find all questions. Bones reaction series, I've only seen on one test. The idea of Bones reaction series is that since magmas, and if you're at my brain's full, I'm done, dude, don't worry about this. We'll end the video with this a little bit here. If you're interested in igneous rocks, we know that magmas are a mixture of minerals, and different minerals have different. It's essentially a freezing point. The way that water, right, is a liquid, but freezes at 0 degrees C. Magma is a liquid, but freezes into a rock at way higher temperatures. But the thing is that all of them that make up the magmas have different individual freezing points. So as a magma progressively cools, it may form different minerals as it goes. And you can actually change the composition. That's getting complicated. This question, number 8, if you stuck around in the video, congratulations, I'll give you the answer. Which statement is most Bones reaction series? Most minerals crystallize at the same temperature? No. The whole point of this is that there's a whole bunch of different temperatures. Most felsic minerals usually crystallize before most mafics. So felsic minerals are these guys. I'm seeing the mafic ones is going first. Muscovite, mica, and quartz are the last minerals. No. Biotite mica is the first mineral to crystallize as magma cools. Uh-oh, I'm not liking any of them. The last minerals. Oh, yeah. I was going too fast. It's 3. These 2 are the last to crystallize as it cools. Very unlikely that anything with that would show up on your regions, even if this were a normal year. All right. Excellent work. On to the lab.